everyone, welcome back to another Math 9 video. We are starting chapter 7 today, and that is Inductive Reasoning to find a specific term. I just really like this quote, so I wanted to start off by reading this. A mathematician, like a painter or a poet, is a maker of patterns. So we are going to be focusing on patterns in this chapter. So it's about noticing patterns and drawing conclusions from them. That's actually what we do in society to make sense of what's going on, especially with what's going on right now with the pandemic as well. We look to see when else in society this has happened, and then we use that to try to draw conclusions from it, find any helpful information. And so actually all of mathematics is understanding patterns. That's what equations are too. It's taking a look at something that happens over and over again, and then coming up with a pattern or an equation to represent that. And it's a tool to help us to simplify things. Okay, so it says in science this would be called experimental or scientific method, and in math this is called inductive reasoning. So here's what inductive reasoning is. Noticing patterns in specific examples and drawing conclusions from them based on educated guesses. So let's dive into a few examples where we can start to see how that happens. So I feel like the first one is quite visual. You can almost start to get a sense of what's happening just by looking like visually at the image that it sort of creates. So something that stands out to me and to my eye is that there's a 1, 1 there, there's 2 1s there, 3 there, 4 there, and 5 there. So almost like if I were to set them up symmetrically, it would sort of make a triangle that seems to be getting bigger at the bottom, or a pyramid. So, and then I'm looking at it and it stands out to me that there's 1 1 there, and then I have a 1 in my answer. There's 2 1s there, and there's a 2 in the middle. There's 3 1s there, and I see a 3 in the middle. So I'm thinking it goes 1, 2, 3, 4. So basically the number of 1s that are represented there is the number or the value that goes in the middle. So here's what we end up getting. And then if there's 5 1s there, well, we have 1, 2, 3, 4, 5. And then again, we reduce this. So 4, 3, 2, 1. So you can start to see the pattern that's happening there, where the number of 1s that are being multiplied, so 5 1s times 5 1s, ends up being the number that goes in the center. If there's 5 1s times 5 1s, I have a 5 that goes in the middle of my answer, which is pretty cool actually if you take a look at the pattern that it creates. And you can of course start to see what's going on and how to make sense of this. Okay, so now that you've seen that, maybe you could take a minute to pause the video and try this next one on your own. This is pretty impressive that this is really what happens. So we're trying to find a pattern based on what we see happening here as well, and you can always take out your calculator after to double check if this is true, but this is pretty impressive that it is actually true. So there are lots of numbers in nature that come up with these amazing patterns. So 6 times 7 is 42, we all know that, but then we look to see that 66 times 67, we're multiplying 66, there's 2 6s there, there's also 2 4s followed by 2 2s in our answer. If we have 666, so that's 3 6s, then in our answer, and it's multiplied by 667, in our answer we have 3 4s followed by 3 2s. So you're starting to see this pattern. Based on what we see, I would predict that if I have 4 6s, I'm probably going to have 1, 2, 3, 4 4s in my answer, followed by 1, 2, 3, 4 2s. when I multiply that by 6,667. And of course, you could take your calculator and multiply this out to double check, but that is the pattern that it ends up following. At the end, I have 1, 2, 3, 4, 5 sixes. So 1, 2, 3, 4, 5 fours, followed by, or multiplied by 1, 2, 3, 4, 7 at the end. So 66,667. So if there's 5 fours, it's also going to be 1, 2, 3, 4, 5 twos at the end. So that's pretty cool. It shows you the pattern that these numbers end up naturally forming. Okay, so looking at the patterns showing up in a slightly different form, we have a series of numbers that are written here in a pattern, and we're trying to figure out the relationship. What's going on between these values? Now, the nice thing about this stuff is I think that it shows up or stands out to different people in different ways. I want you to find your method of what makes sense to you. So, one pattern that I notice, well, take a look at this. I see a relationship showing up in pairs. So if I take a look at this, well, we're trying to figure out what's happening here. We can see, I'm seeing here, if I do 3 times 2 and I add 2 to it, I would get to that value. And if I do that again here, I multiply by 2 and I add 2, I get that number. So that's something that's standing out to me. If I do that again here, I multiply by 2 and I add 2, I get to that number. So for me, if I follow that pattern and I do that again, I should be able to multiply by 2 and add 2 to give me this number or value at the end. So I would get 78. Okay, so then I also notice another pattern. And again, there's multiple ways of doing this. This is just one type of pattern that I'm pointing out to you. I encourage you to find as many different ways as you can so that you can start to look and think in terms of patterns. Then maybe to show it clearly, I'll do the other one at the top using a different color. I guess I want to, so I've been doing every other number. I started with the first one and then I skipped a number and I took that path or that pattern to get to the end. So maybe this time I'm going to look for a relationship that I see happening. Sorry, this one was supposed to be a 16. That makes a lot more sense. My apologies for that. I just noticed it was missing. So if I take a look at that, I notice if I go from here to here, again, just sort of following the same pattern that I was using at the bottom, I could do multiplying this by 2. If I multiplied that by 2, I'd get 12, but I end up at 16, so I can add 4 to it. So multiply by 2 and add 4. Okay, so again, there was a value missing there, so let me add that in. Again, I could do the same thing, taking a look at my next value. So if I went from here to here, let me see, does my method work? If I multiply this by 2 and I add 4, well, 16 times 2 will give me 32. I add 4, I do get 36, so that pattern does work. So if I do that same thing over here and I multiply by 2 and add 4 to it, according to this pattern of every other number that I'm looking at, then I should get 76. Okay, so we can start to see how that pattern makes sense. And then another way that we could look at it is I also noticed this. If I zoom in on these, 3 and 6, well, 6 is double 3. And then if I look at the next two, 8 and 16, I'm going to do this underneath. So you can see that 16 is also double of 8. So that makes sense. 18 and 36, yeah, that makes sense. So the two numbers that are side by side have a relationship. So 38, if I multiply that by 2, I do get 76. So this whole pattern makes sense as well. There's another way that I see a pattern standing out to me. So there's lots of different ways of approaching this. Find the pattern that makes sense to you and just test it out and double check to see that what you're doing actually does work out. So let's try this next one together then. If we have a set of numbers that look like this, again, I would suggest that you pause the video, try this on your own, and then hit play again when you're ready to check your solution to see if you've gotten it right. So again, we're sort of looking for a pattern. My first step would be I would look at them side by side to see is there any pattern happening side by side. Kind of like last time, I do see one that's kind of happening here, and that is that 4 is double compared to 2. 5 times 2 is 10, 12 times 2 is 24. So then based on this, sorry, I've cut off the last number there, I would say just by looking at this, that this next number must be 54, because I'm just multiplying them by 2. Okay, but then that doesn't really help me because I wanted to figure out what the next one is after that. So am I able to find another pattern that's going to help me to get to that place? So if I take a look at that, well, let's see, is there anything else? My next thing I would look at is if I go 4 to 5, that's plus 1. And if I go 10 to 12, that's plus 2. And if I go there to there, that's plus 3. So based on what I see happening, going there to there, I should probably go plus 4. Okay, so 54 plus 4, so I should get 58 there. Okay, so that seems to follow the pattern and the rules that I see going on, and that would be enough. We've filled in the blanks, we're good to go, but I just want to show you one other pattern that might have stood out to you first or that will accomplish the same thing. And that is if I look at going from here to here, so skipping each value, I would do multiplied by 2 and I would add 1. And then if I go from here to here, I would do multiply by 2 and I would add 2. And if I go to the next one, I would do multiply by 2 and add 3. So it's the same thing as the pattern we saw going on previously. And to get to here, I would do multiplied by 2 and add 4. So it just shows you another way of looking at the same thing. It ultimately is the same thing, but just a different way of writing it. Okay, if we have a diagram that looks like this, it says determine the number of line segments in the 100th diagram. So right now we have these 4 diagrams. Well, maybe what would be helpful is for us to take a look at the number of line segments or sticks that we have in each of these. So if we were to count this, I'd have 1, 2, 3, 4, 5, 6. So I'm going to kind of create a chart. Instead of line segments, I'm going to just call them sticks. So in the first one, I have 6 of them. I want to count up how many I have in the next one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would have 11 there. And here, well, I know that first two have 11, so 12, 13, 14, 15, 16. So I have 16 there. I know that the 3 would have 16, so 17, 18, 19, 20, 21. I know that would have 21. And if I were to keep this going, I'm looking for ... 100. So clearly, I don't want to sit there and draw 100 diagrams, like how the fourth diagram has 1, 2, 3, 4 boxes in it. I don't want to draw 100 of them. This is why we come up with equations. This is why we look at patterns, is so that we are able to take large numbers and we're able to do these calculations without having to sit there and drawing out all 100 of them. So I'm trying to find the patterns in this, kind of similar to like what we did with those sets of numbers in the last example. So what I notice happening here to here, well, if I go from 6 to 11, that's plus 5. If I go from there to there, that's another plus 5. Then if I go there to there, that's also plus 5. So this is actually nicely going to tie in with the linear equations chapter we did not that long ago. Remember y equals mx plus b? Well, this follows a similar type of pattern. We would take the number of sticks, okay, and we would take a look at the difference. So remember, we've talked about common difference. This plus 5 is like the common difference that comes up. I'm going to call that 5. I'm going to call this diagram number n. We've used this in the past, so 5n. And I'm going to try to figure out a pattern or an equation for how to come up with a number that's here. So if for diagram 1, I would plug in a 1 here, and that would give me the number 5, but I end up at 6, so it must be 5n plus 1. So I'm thinking that this pattern helps me to come up with the next diagram, or the number of sticks that I have. So, well, actually, let me say that here, equals the number of sticks. But I better double check to see if this is correct. So how I could double check that is I could take diagram number 2, whoops, that's not what I wanted. I could take diagram number 2 and say, okay, so there's 11, there should be 11 sticks in there. So if I plug in a 2 for diagram number 2, well, 5 times 2 would be 10. 5 times 2 plus 1. So I should get 11 sticks, which is what I actually have there. So I know that my equation actually is true, and this really does make sense. So 5n plus 1 would be my equation. Now that I know that, so this I use to check to see if I'm correct, then, therefore, that's what these little dots mean, I can use that to figure out what it must be for the 100th diagram. So 5 times 100 plus 1 means in the 100th diagram, well, 5 times 100 gives me 500 plus 1. So I would have 501 sticks. So this would be my answer. In the 100th figure. This is a little bit difficult. I know that a lot of people have troubles with this, so I'm glad that you have the video so you can pause or you can go back to it to make sense of this. But I think I will also show you one more example to help make things a little bit easier for you. So determine the number of squares in the 100th diagram if we see that this is what we have going on here. So if this is diagram number 1, diagram 2, and diagram 3, This time we're looking for the number of squares, not the number of sticks. So let's maybe come up with the number of squares. So I'm going to set it up kind of like a chart here. So the number of squares in the first diagram is 2. And here we would have 2, 4, 6. And here we'd have 3, 6, 9, 12. So we want to eventually come up with in the 100th diagram. Okay, let's take a look at the pattern. So in the pattern, I want to try to use my n value to help me to figure this out. So, okay. I know that in order to get this, I could do 1, which is my n value, times 2. So this is my pattern. And for this next one, if the answer is 6, I could take the diagram number 2 and multiply it by 1, 2, 3, or the number of rows. So let's see if that works here. Take my diagram number and then multiply it by 1, 2, 3, 4. So basically, I multiply it by one number larger than what the diagram number is. So according to this pattern, for the 100th diagram, I should multiply 100 times 101. And that gives me 10,100 as my answer. Okay, so that's the last example. I'd like for you to do numbers 1 to 5, and that's the end of this video.